Well, good afternoon. It's certainly my pleasure to be here today, and I would thank Gresham College and the Museum of London for inviting me. And I look forward to telling you a little bit about some of my research projects that are going on right now concerning shale gas. But before I get started, I just say that I'm really happy to be back in the UK again. As a college student, I actually studied at the University of Newcastle for a year and was a student intern in Scotland. And so it's just wonderful to have this opportunity to come back because everybody treated me so well as a student, and now they are as a visiting professor. To get started today, my objectives are to introduce you to some of the issues related to shale gas extraction, issues that we have looked at in the United States because we've been doing this for several years now. And what we want to do is explore and see what the American state governments are doing. The federal government decided it really didn't want to regulate this very much for political reasons or whatever. And so the states are really doing that. And so we need to look at some of the information out there and discern what's going to happen in Europe and in the United Kingdom. So I'd first ask you a question. What are your expectations from an American professor talking about the environment and shale gas? Am I going to be this environmentalist wearing my Nature Conservancy hat of an endangered species? Anybody think that? No? Well, am I going to be the Texas cowboy who wants to continue with the business model that we have in the U.S., and that is drill, drill, drill? It is amazing what we have done in this country, in the United States this is, what we have done in my country, and how accepting the people have been. And when I wear my environmental hat, and that is most of the time when I'm teaching, I'm just flabbergasted at how slow some of the people are to recognize the environmental problems out there. But I want to share them with you because it isn't necessarily impossible to do this, to have business and to also get this shale gas. And my thoughts are that we can wear both hats, and that's what I try to do. I try to look at the evidence. And you have to realize the evidence is not always clear. A lot of people look at science and say, well, science has to be one thing or the other. Well, there's mixed results, and it's certainly the same for shale gas. There's different tests done, different scientists do things, and they come up with a little different result. Now, to get started, where did the first gas well originate? It actually originated 3 miles from my home in western New York State. The first gas well was in 1825 in Fredonia, New York, and the gas was used in 1825 when we had a famous dignitary come, and for some reason he was out in rural western New York, and this little village wanted to impress him, and so they did with their natural gas lights. Now, this concerns all of you because Europe has shale gas, and the question is, do you want to use it or not? And it appears that every country is going to make their own decision, and actually that's a good idea because countries are different, and they have different reasons for proceeding with it or not. For the United Kingdom, you have significant quantities of shale gas. So far, you aren't sure you want to tap into these because of the environmental and health problems. So the question is whether it can be done safely, can it be done responsibly? And to do this, you really have to have the government involved. You need to have some type of regulation, otherwise these companies cut corners, they do a bad job, and you will have environmental problems, you will have public health problems. But if it's done safely and wisely, these problems are minimized. Now, this concerns today hydraulic fracturing, which is the pressure used to open up the shales to get out the hydrocarbons, and it involves horizontal drilling, and we'll look at that in just a second. Question that we might ask is, can we separate hydraulic fracturing from the drilling? And this is where we have one idea coming from the public and another from business. The oil companies say, well, hydraulic fracturing's safe. It's really safe. Well, the problems actually come from the drilling. It doesn't come from the fracturing. But yet you can't have hydraulic fracturing without drilling, so you have it all together. So the public lumps it all together and calls it hydraulic fracturing. The industry says hydraulic fracturing's safe, there's no problems. And they both aren't completely true, but that's the way it is. So we had conventional wells for a long time, and the conventional went down into the rock strata, into rock that was porous, and so the hydrocarbons could flow to the well and be pumped up and be used by society. Then we have these unconventional wells now, which is a category that covers a number of different types of technologies, and that's what we're going to be talking about mostly, because this is where the hydraulic fracturing is necessary if we're going to actually get the hydrocarbons out of the ground. It's necessary because these hydrocarbons are held too tightly in the rock formations underground, and they won't automatically flow to a conventional well. So we have to do something about it, and what we do is we fracture the rocks. We fracture it with hydraulic pressure, and you can see as the pressure increases underground, you actually will have the little fracks. I mean, they don't look like that. They're just little things like hairs. And through these little cracks, the hydrocarbon can flow to the pipes and be extracted for our use. Now, in the U.S., shale gas has become really important in a very few years. As you can see here, we have about 40% of our natural gas usage in the United States coming from shale gas today. That is just amazing. That amount is tremendous. And what it has done is it's changed the American economy, and I have a few figures on that. It's also changed our electricity sector because we have electricity plants switching from coal to natural gas. So what is shale gas? Well, I've kind of told you a lot about it already. It's gas in rock strata, which was previously not available for extraction. It didn't flow naturally, so you couldn't collect it without this new technology. But actually, it's not new technology. Fracturing's been around 50, 60 years. It's not new. Horizontal drilling's been around dozens of years. It's not new either. What is new is we're using it extensively to extract oil and gas resources in the United States and Canada and other countries in the world. The use of pressure is what hydraulic fracturing is about. You have the equipment to pressurize your well. You have your well drilled, and then you insert into the well something to pressurize a proppant or sand into the rock strata deep underground. Most of these are using water. Water as the liquid, and then we add chemicals and sand and other items to the water to make it work better in the well. However, it can be done with other media. And we put it down under high pressure, and section by section underground, we will frack the well. So drillers under horizontal drilling can actually change the direction of the well, and this is what makes it feasible to get this natural gas out of the shales. The shales under the ground are horizontal, and so if you have a vertical well, it doesn't work very well. But if you have a vertical well go down to the horizontal level, and a mile or 2 miles underground in most cases, then you can follow the bed of shale that has the hydrocarbons. And by following that bed, maybe for a mile or so, you have lots more chances to harvest the hydrocarbons. And so that's what we are doing with shale gas extraction. For the actual fracturing, we start at the very end, so we would only fracture a small stage at a time. The engineers figure out how to do this, that they only do a little stage, and then they release it and do the next stage. And you have to do it this way because you want the sand and the proppants to go in the shale here first. You can't do it all together because you don't have enough energy to do it all together. You only want to do a small area at a time. And so this is what they are doing deep underground for hydraulic fracturing. So it's the pressure here that's the fracturing, right? It's the pressure. And anytime you exert pressure underground, there is a chance that there's going to be a little displacement of the ground. Whether you're fracturing, whether you're injecting other fluids. And a number of you have probably read about earthquakes that have been occurring in the United States, especially in the state of Ohio and Oklahoma. These earthquakes are actually not from fracturing new wells, they're from injecting the fluids from fracturing in different wells deep underground. And those are injected under pressure, and the pressures have caused the earth to shift. So it can be a problem, but again, the engineers, this is their technology to figure out how much pressure to put on here. When they actually fracture a well, they have equipment on top of the ground to see if they can feel the fracture. And if they feel the fracture, they know they got to use less pressure, basically, because they don't want to feel the fracture on top of the ground. Developing a well is big business, and obviously it's something that is hard on the roads and the community or the property owners next door. There's lots of equipment that has to come in here and to not only drill the well, but then to put in the water and the fluids, and it's actually all the water that has to come to the site that is the major problem. Now, in the United States, we all aren't happy with fracturing either. We have people that are for it, and we have people that are against it. Most of the U.S., except New York and New England, are for it. They're for it because of the jobs, the economic development that's occurring, the less expensive energy that we have, and the reduction of dependence on foreign oil and natural gas, because we're also getting oil from this new technology. In 2013, 2 years ago, we had 47,000 new wells drilled in the United States. Wow, can you believe that? That's a lot of wells. Now, obviously, this was a high water mark because the prices are down now. They aren't drilling now. But, you know, we were going very strong back in 2013. We've performed over 1 million frac jobs. This is not new technology. As I said, the technology has been around 60 years. We're doing it all over. We do it not only on these new unconventional wells, we also realize we can use fracturing at the old wells. At the old wells, the vertical wells, we can also fracture, and it causes the rocks to release more hydrocarbons. And so it extends the lifetime of a well. Moreover, most all these wells now are going to be fractured more than once because the engineers realize there's still hydrocarbons there that we can retrieve if we refracture it. And so they will refracture it when the well diminishes its output. Again, this is all engineering science. They figure out what to do, whether it's worth refracturing or not. And if they're on refracture, of course, they got to bring all this equipment back in. And this is a problem because it's the equipment coming in that causes a lot of the issues in the community. But for the U.S., this year we anticipate there'll be 869,000 jobs related to hydraulic fracturing and shale gas development. Capital expenditures of $48 billion, federal taxes of $14 billion, state local taxes of $13 billion, lease payments of $286 million. And electricity costs are going down in the United States. They're down about 10% because of this natural gas. The gas prices obviously have gone way down too. We actually have too much gas like a lot of the world does right now. And so the prices are low, which makes electricity lower in the U.S. For prices, the interesting thing here is prices of natural gas in the United States are lower than the rest of the world, basically. And that is because of this hydraulic fracturing. And so you can see the prices are going down. And for natural gas, they've gone down even more. And the global natural gas prices, this is what I was alluding to. The U.S. is at the bottom. And in the middle is the UK, and Asia's at the top. This shows you the different prices for natural gas in the world. So America does have a competitive advantage at the moment because we have cheaper gas than the rest of the world. It's cheaper for two reasons. First of all, because we're engaged in hydraulic fracturing. Second of all, we happen to have shale formations that are fairly easy to fracture, and we happen to have the know-how, the technology, and the infrastructure for all of this. And this is important because we hear about all this shale in Europe and how we should be fracturing it here, and yet the experts predict that if we were to fracture anywhere in Europe, the wells would cost at least twice as much as the wells in the United States. And in some areas, the shale formations are so deep and they aren't as willing to relinquish the hydrocarbons. It'll probably even be 3 times as much to drill and fracture a well in certain places in Europe as opposed to the U.S. So the U.S. has been lucky, but at the same time, by being first on the block, we have had a lot of problems, a lot of environmental problems, and we can talk about this in just a minute. But we approached it. We like new technology in the U.S. in general, and the oil industry, at least during President Bush's administration, was given very favorable treatment to continue to develop oil and gas resources. Exceptions were passed to federal law to deregulate the industry or to deregulate the environmental infrastructure that was controlling some of their activities, and that led us to engage in this fracturing. Now, what we're concerned about are the people's health, the environment, and the social problems that accompany the use of this technology. And so we'll talk about these in turn. The meaning of these concerns is that current information may lead to different conclusions of whether we want to proceed. And this is why in Europe, some countries may want to proceed with fracturing. Other countries may decide, no, it's really not for us. We don't need the resources that badly, and we're concerned about human health. We got a lot of people. We're concerned about our environment. We don't want to ruin it. And so we might have fracturing in Poland, but not in Denmark. We might have it in Eastern Europe and not in Western Europe, things like that. We also saw these differences in New York and Pennsylvania. Pennsylvania has gone ahead and is fracking rapidly. Thousands of wells have been drilled there in the last 5 years. New York, we also have the Marcellus Shale in New York. We have not allowed any unconventional wells to be drilled. The governor, first it was a Republican governor, stepped up with a moratorium, said, let's research this question. Let's look at the public health and environmental issues before we allow it. Then we have a Democratic governor, and he happened to agree with the previous administration, continued it. And then the Department of Health for the state of New York gave a lengthy report, which the governor used to say we are not going to engage in unconventional shale gas development. So they aren't going to do it for a number of reasons, but public health and water quality were 2 of them. The interesting thing is we are not doing it in unconventional wells in New York. We actually are fracturing in conventional wells in New York. Most people don't realize that you can use hydraulic fracturing in the conventional wells. New York has old gas wells, so we're using fracking in New York. So can we safely extract shale gas? That's the question. Are more regulations needed to protect people and the property and the public? And who should pay for the damages that are caused? This is always a problem. Should the government, the public have to pay, or should the extracting industry pay for all of this? Well, drilling sites are accompanied by 2 major problems. First are the fluids, and second are the air quality. To drill a well, you'll probably want about 2 hectares of land, about 4 acres, and you're going to have a lot of equipment come in, noise, and trucks, and lights, and bad poisonous fluids, and all of this stuff will be brought into the site. You obviously don't want to live close to one of these. And unfortunately, in some states, when they started doing this, they didn't have long setback distances from houses. And so if your neighbor happened to own property within 200 feet of your house, they could drill a well right next to your house. That's pretty miserable, right? Really miserable to have all this stuff right next door. And of course, then you have all the trucks bringing the water to the site. We need millions and millions of gallons of water, about 4 million gallons we may need for a single well. We have all this equipment coming in to drill the well and then to hydraulically frack the well. So you see all of this. And there are health concerns. Health concerns, the biggest one are gases and the sand in the air. And the sand is a problem because of the type of sand what we're using. We have to use glacial sand, and I'll talk about that in just a minute. Concerns about pollution. If we have a well here, what happens if there's a spill? The rain washes it right down into the river. What happens if we take too much water out of our streams to use in fracturing a well? This water is lost forever. So we have this fresh water being used to fracture a well. It's injected underground. If it comes up, it's full of chemicals. Some of it are toxic, so we can't reuse this water. So this is a problem. And then the sand. This is a sand pit in Wisconsin. It's glacial sand. If you think about it, there's different types of sand. What kind of sand do you want to use for fracturing? Do you want to use the round sand that comes from the beach or a river? Or do you want to use angular sand that was made angular when the ice sheared it off the rocks and deposited it, the water deposited it in an area here that we're mining now? And the answer is that if you use little round balls, when you put them in the rock, they'll all get together and your hydrocarbons can't get past these round balls. If you use angular sand, just think of triangles, then the hydrocarbons can get through the holes and you'll have a higher recovery of hydrocarbons. So obviously we want to use this angular sand. Well, if you have to breathe sand, what kind of sand do you want to breathe? Well, you want to breathe the round sand, right? Because if you breathe the angular sand and it gets into your lungs, it's going to tear them up. And you don't want your lungs torn up. And so the sand that's used at these wells is dangerous in the air. And the men that are working there, if they breathe in too much of this sand, they're obviously going to have lung damage. Then we can have mishaps on the road. The more traffic you have on roads, the more mishaps you're going to have. Pipeline construction going through the fields or through the forests. You have to have pipelines because natural gas is methane, right? And to ship methane, unless you want to get it real cold under pressure, you use a gas line underground because it's a gas. So you have to connect all of these wells to a distribution system to get it where you want to go and to fix the gas so it can be made into usable form to be used at a facility. So you're going to have pipelines. Of course, the alternative is to put it under pressure and to carry it in railroad cars, right? And that's what we're doing with the oil that we're getting from North Dakota. And that's what we're doing with some of the oil that we're getting from Western Canada. And what happens when you ship oil by railroad trains? There's accidents again, right? And we're debating right now in the U.S. at the federal level and state levels what to do about these train accidents because the oil is exploding when there's something bad happening and it's damaging people and property. And so we don't have this with methane, so the natural gas is in pipelines. Of course, you have to do the pipelines right or you're going to have a problem also. Then erosion and sedimentation. Anytime you disturb an area to build a pipeline, you're going to have this occurring. But the U.S. has decided we want to maintain our energy supplies, and so this is what we're doing with this technology. Public opposition. New York had wonderful parades in opposition of this several years ago because it took the governors about 4 years to finally come up with this permanent moratorium that they currently have. I mean, it's permanent in that it's there, but the legislature of the state of New York could change their mind and decide to do differently. So don't frack New York. Okay, hydraulic fracturing. What are the roles of governments? Differences in the United States and Europe. I think the U.S. is willing to do a little more than Europe on using new technology, and then if there's a problem, well, we'll have new technology to fix the problem, right? Whereas Europe likes to wait, and can it really be done safely? Let's not do it until we know it can be done safely. And so in this case, you're watching the Americans to see if it can be done safely. And you're going to have to decide for yourselves whether it can be. So 2 models have been identified to address the economic, environmental, and social aspects. That's what we're worried about. We're doing it because of the economics, but we're worried about the social and the environmentalists. So we have this Mickey Mouse model, we have a bullseye model. Guess what the U.S. wanted to use? Yes, we used the Mickey Mouse model. We're mainly concerned with the economy. Let's make money. That's what oil companies do. And the environment's out there, society's out there, yeah, we think about them on the side. However, we should be using this bullseye model. We should be looking at our economy, but realizing it's part of the big picture of our lives. It's part of society, it's part of the environment. And so the question is, how can we have an economy that's successful, that doesn't denigrate the environment, doesn't denigrate people's health? Now, the problem with all of this is there's time lags for regulatory controls. We can have governments come in and regulate this. In the United States, we've had problems because the federal government said, well, we don't want to regulate this really. We granted these exceptions in 6 or 7 different laws, at least that many, for oil and gas production. So the states said, well, golly, we got to protect our people. So the states have had to deal with this state by state. And by doing this, the states weren't always ready for all the problems, and because it was technology that hadn't been used on a wide scale, there were new problems that we didn't anticipate. And so there have been problems that have occurred. We're worried about the health, environmental, and social aspects. Do these only relate to fracturing, or is it something else? We've already mentioned it's actually the well drilling that is causing the problems. And it's the other activities that are causing most of these problems, because we need hydraulic fracturing to even have these new wells, we just call it all together hydraulic fracturing. But really, it's the extraction of these resources using this technology in one part of it that gives rise to the problems that we're concerned about. The activities of shale gas production cannot be separated from fracturing, and all of the activities involve risks, and many of the risks are associated with drilling, and they have been addressed for decades. And so what you have to realize is anytime you have a new industrial activity, there are risks. And we have to determine, can we live with these risks? Are the risks small enough so we still want to proceed with the technology? And this is what we've decided in most areas of the United States, that they could be small enough that we wanted to proceed with the technology. However, New York, New England's decided differently. They said, well, we really don't know enough about the long-term health involved with new wells, and so we will wait. We won't develop our unconventional wells at this time. So the problem isn't hydraulic fracking. The problem is the activities that surround developing a well. With fracking itself, the problem involves the toxic chemicals that are used. 95% of the fluids are water and sand, and the other 5.5% are additives. They're fluid additives that serve a number of purposes to maximize production of the hydrocarbons underground. So we use 2 to 4 million gallons of water at a well, about 500 gallons of chemical additives. This varies from area to area. We call the shales shale plays, and the plays have different properties. They all aren't the same. And so if you're drilling in Texas, you might have the Barnett Formation or the Barnett Shale Play. If you're up in Pennsylvania, you have the Marcellus Shale play. And there's different chemicals that you might use, different depths that you'll go, different amounts of pressure that you'll use to push the sand into the rocks. So the fracturing fluids are actually different at different locations. And this does make regulation of them a little more difficult. And this is one of the reasons the feds didn't want to do it. They're going to have to be different everywhere anyway. So they said, well, we'll let the states do it. Now, the chemical additives are added. Usually, we only use 8 to 10 at this point. There have been over 700 or 800 tried. There's lots have been tried, but we realize some are superior to others. We want them as an acid, the acid to melt some of the rocks that are being drilled out, a scale inhibitor to prevent scale, a biocide. We don't want things to be growing, an iron controlling or stabilizing agent, a friction reducing agent, a corrosion inhibitor, and a gelling agent. So we use a lot of different things here, and again, now there's not that many being used, but it depends on the formation. The problems with the chemicals being used are, some of them are toxic. Not all of them, just some of them. And of course, how much is toxic? Well, that will depend on the well, which ones are used in the particular well. And the question is, if we have toxic chemicals used, how are we going to regulate them? Well, this is a problem. They are not regulated under federal law because of an exception to federal law instituted in 2005. So we aren't going to regulate them at the federal level, so it's at the state level if you want to know about them. Well, the states have proceeded state by state with their own rules. And again, what are these rules? There's two answers. The oil companies say under state law, all of them have to be disclosed. And the environmentalists say under state law, they all have to be disclosed except those the chemical companies don't want to tell us about, because there's a trade secrets exception. Anytime a company claims that one of these chemical or the processes is a trade secret, they don't have to disclose them. Of course, the industry doesn't tell you about this exception, right? They just say, well, look at the state law. It says we have to tell you all of them. When we tell you all of them, they have a manifest. There's a manifest with each well telling you what chemicals are being used, except it doesn't have the full disclosure of trade secrets. It might have the family name. Well, it has to have the family name, but not everything. And so this is a major problem. Major problem for first responders, emergency personnel, fire people, and doctors. I mean, how do you fix a person's health if they can't tell you what chemicals they've been exposed to? It's not very promising. And of course, if you think you're exposed, you can get this information from the chemical company. I mean, it's registered somewhere out there. And they will provide it to you. They've made doctors and medical personnel and others sign confidentiality agreements saying, we know what it is, we will not tell anybody, not even another doctor. I mean, that doesn't work very well, right? If you're getting medical attention, doctors need to be sharing their information, not keeping it confidential. So we do have a real problem here in the United States, one that a lot of people are aware of, one that the industry keeps fighting, keeps misinforming the people, actually, because they tell everybody, oh, we disclose everything. We have this Frack Focus site that, go there, you can see what's being used. Yes, you see everything being used except those that are kept as trade secrets. So what can we do about this? Well, we're working on it. We're trying to get states to change their laws because we really think that people that may be injured or property owners next door ought to know what's going on. They ought to know what chemicals are out there so they can make decisions on how they're going to act. I mean, if you want to buy property and there's a well next door, you want to know what is being used at that oil well next door. And right now, you don't have that possibility. So how can we convince governments? It's a long process. Just last week, The federal government came out with new regulations in the United States for drilling on public lands. The Bureau of Land Management under the Department of Interior came out with their new rules. They're already being sued over these rules in federal court. As you might expect, the oil industry is not happy with them. But the new rules said if you drill on federal lands, you will disclose everything. And that's something I happen to agree with. So, people have these sensible rules, they just haven't been put in place by legislators. Encouraging better activities. The next issue I'd like to share with you concerns best management practices or just simply management practices. Do we require any management practices at these wells? And right now they're voluntary. Right now the industry chooses the management practices to minimize damages. They realize that if they do something wrong, they're going to be sued for it. They can be sued in common law tort. They can be sued in negligence. They can be sued for a trespass. They're all aware of this. So the industry does have incentives to do it right. But at the same time, are there enough incentives to do it better? And that's the question we have to ask. And just glancing briefly at the new federal rules this past weekend, one of the rules concerns the use of fracking fluids and how much you have to disclose, and another rule concerns how much you have to recycle, things like that. And so some of the new possibilities out there are wonderful for these management practices, and this is what we should be moving towards. And an example of this, I have a non-governmental organization called the Center for Sustainable Shale Development. It's actually sponsored by environmental organizations and the oil industry. So I haven't decided yet, does one side weigh in more heavily than the others? They've come together jointly and collaborated to fund this center in Pittsburgh, Pennsylvania, and they've come up with 15 best management practices. They came up with these last year, and to me, they look like a good idea. They're best management practices that are doable, but yet they improve the standards of drilling a well and fracturing a well in the areas if a company wants to be certified under this sustainability center. And so it is open, and Chevron was the first one. Chevron is one of the big companies that helped sponsor this center. They were the first ones to be certified last year. About 2 weeks ago, the second big oil company, Shell, was also certified. It's also donated to this center. So again, who knows what's happening, but it's better than nothing, right? It's an excellent start. And to me, it raises the question, if this NGO, if this center can come up with these management practices, why can't legislators say, hey, we like these management practices so much, let's adopt them as a regulation for our state? And that's what I'm hoping will happen. So the certification's only valid for 24 months. So you might ask yourself, why does Chevron want to be certified as being a good guy for only 24 months? And the answer is technology's changing. In 24 months, the center will have different best management practices, presumably. I mean, who knows? We don't know what's coming down. But the center already realizes this, because if you read some of their best management practices, it has dates incorporated into them. And by 2014, you had to have this technology. 2015, you have to have a better technology. So this is a great idea to improve the technology, the management practices being used to extract oil and gas. Now let's look at two examples here. The first one's about recycling wastewater. One of the problems is that the wastewaters were not being recycled, and instead they all had to be carted in Pennsylvania to Ohio, where they could be injected deep underground, and this was causing a lot of problems. This is what the earthquakes in Ohio are about. So the center comes up with this idea, let's reuse them. Well, it's not a new idea. We all could have guessed that a long time ago. But the center says, we'll put a 90% mark here. That's a great idea. We're going to make them recycle 90% of these fluids. This way, we'll have a lot less to discard, and this way, we'll actually be reusing some of that water. It's not fresh water anymore. After it's been used in fracturing, it's contaminated, but it can be reused in a well down the road, a few miles down the road. So that's what we will do. So this is a great idea, and this is one of their standards that has come up with this center. The next one is a standard for pits for drilling fluids on the surface. Now, this has been a problem because historically we allowed them to have a pit on the surface that they stored these fluids before they used them in the well. They'd put the fluids in there, and then they'd pump the fluids into the ground when they were fracturing the well. Well, we all know if you have a pit on top of the ground, there's going to be contamination, right? I mean, accidents happen. That's not intentional contamination. Accidents happen, and they have happened. So the center came up with this idea. Again, it's not a new idea, but they just said, for our management practice, you cannot use these open pits. Instead, you have to use a closed-loop system, so it's all contained all the time. Sounds like a good idea, right? This is an idea that the Bureau of Land Management actually put in its new regulations last week, and one of the issues that the oil companies are not happy with. They don't want to have to use it. It's more expensive to have a closed-loop system, obviously. But again, you may need it to prevent accidents and contamination problems. Of course, the other issue is fracking in Pennsylvania and the Marcellus area a lot different than in Texas? And the answer is yes, it is, because there's different amounts of rainfall, different soils, and all of that. I don't know if pits are okay in Texas or not. I can certainly see why they aren't okay in Pennsylvania. I mean, they get rain there, and if you get too much rain, the pits could overflow. So we need to continue examining each stage of well development here to determine what type of best management practices can be used. The University of Colorado has hundreds of best management practices that have been incorporated by states and local governments to choose from, and we certainly need to be looking at these in more detail to see which ones we really need to make mandatory, which one a government needs to come up with a regulation saying, if you're going to drill a well, you'll use this technology so there'll be fewer accidents, less risks to the environment and to people's health. So the insights from our American experiences for you are that citizen governments need to learn what risks are out there. The problems are not adequately addressed in all situations. Which ones are not being addressed? And again, as you look at these ideas, you have to realize there's going to be scientists all over the board. You just have to think about climate change, right? We know there's still scientists out there claiming there's no climate change going on, but they're a very tiny minority. Well, the same with issues here with hydraulic fracturing. One of the issues is how much methane is leaking when we drill a well. And we had one study from a major U.S. university that said it's an awful lot, and we've had 4 other studies saying, well, it's really not that much. Which one's right? I mean, well, you can choose your university, or do you choose the majority? Well, you have to determine which scientific experiment was done the best. So there is controversy here about the management practices that can be used, about the economics. Companies are obviously going to drag their feet. If it costs more money, they don't want to do things. But yet there are a few things that it's worth spending a little more money so we save people's health and we save the environment. So returning to my thoughts, I suggested that hydraulic fracturing might have beneficial environment or economic consequences. I think if you look at the United States, you can see there have been mixed evidence here. We've had a lot of positives: lower gas prices, natural gas prices. We've had to import less fuel. That's very good, but at the same time, we've had some environmental problems. And we actually don't know everything about these environmental problems right yet because we don't know the long-term effects, especially of people's health. Are people adversely affected by the leaking gases from these oil and gas wells? So what about the UK and Europe? What should you all do? Well, I think the American experiences provide a lot of insights on how to manage fracturing with a minimum of risk. You can look at some of the American problems and say, well, that was a problem. We aren't going to let it happen here. How do we not let it happen? Well, we have to have the correct infrastructure, government regulation, oversight, so it will not happen. Would some countries benefit from hydraulic fracturing? I think they would, especially in Eastern Europe, where they have very high percentages of their energy coming from Russian natural gas. I think it'd be a great idea if they could have another source of natural gas in these countries. People will have different answers depending where they are and depending what they value. And some people do value the environment more than others. So I think each country and each region will have to make up their own decisions. Of course, the one big question with this, who will make the decision? Do you want your national government? Do you want a regional government? Or should it be some other level of government? And in the U.S., we are arguing about this vehemently in many states. And the arguments are against states by local governments. Local governments feel they should be able to have some control over wells being drilled within their jurisdictions. The state legislators are more favorably inclined to the oil companies, and they don't want local governments making any decisions. And so we have bills and lawsuits going on in several states about these issues. But we're lucky that we do have choices. You're lucky in the UK that you're looking at this issue and you can have your voices heard. We're lucky we can do the same in the US. Other countries aren't as fortunate. Well, I've enjoyed sharing with you my information on hydraulic fracturing today, and thank you for your attention.